Hello, my name is Eli Vandersluis, and I'm a PhD candidate at Ryerson University in Toronto, Canada. I'm also an ASM Student Member, and today I am here with Paul Okrutny, and we're going to be discussing his life as a forensic engineer and working in failure prevention. Paul, thank you for being here today.
Thanks for having me.
We start with just going through what brought you here in life. Okay, how did your career unfold, starting from undergrad working to here at Mitigateway?
You got to taste every single field of engineering in your first year, and then you have to choose at the end of that year where you're going to go. And I chose materials because I recall sitting in our library recalling that a table in front of me is not actually just a piece of wood. It's actually a whole bunch of molecules that are formed together to form this piece of wood, which we've then built the table out of. And that was the beginning of the journey that I guess brought us here today.
Let's carry on from there. So you went through undergrad, having master, the entire thing, both a bachelor and a master's as well?
Exactly.
And so how did that prepare you for your future career?
Well, it was the exploration of the unknown, because I didn't know materials existed. I didn't know that we could look at materials from the same perspective as I was taught to look at. And it led to failure analysis, because product failure and forensic analysis often looks backwards from the evidence that is left behind after a disaster. So a boiler would explode or a building would collapse, and the fracture mechanics of that component will leave behind a trail that a materials scientist is best suited to work backwards from, to understand the modes of failure, the forces that were applied, and can then try to piece together the story of what actually happened.
How did you get to ASM?
So I joined ASM, the local chapter of ASM. They needed a website. I knew how to make websites, and that's where I met my boss at a forensic company that I worked at. What he loved was my ability to just work with my hands on any problems in general. Forensics is a lot of that, and he offered me a job.
Did you think that your time in university prepared you for it, or was it more your work experience? What do you think got you to where you need to be for that position?
It was a combination of everything. Forensics is probably the most random career you can have in terms of day-to-day activities. It was my background and the knowledge I learned in materials that gave me the confidence to understand components and see how they might break. But it was the everything else that I did outside of school that allowed me to enter a job site and have an understanding of how things connect.
So let's talk a little more about forensic engineering. What's the environment like working there? What's your day-to-day tasks? Is it a teamwork oriented workplace, or you're more working on your own? What's it like?
It's a combination. Again, you get a file or a call that there was some failure. Often the person calling is relatively chaotic. They don't really know what happened yet, and so they're not sure who the best person to send to the job site is. So you end up being sent to a job site and doing analogous to a triage in a hospital. So you get there and you realize what actually happened and what expertise you might need. Often your own personal expertise are enough, and sometimes you have to expand and build a team of people that will be able to solve that issue with you, or alongside you at least, in order to solve that problem.
So it seems like you'd be favoring more creative problem solving as opposed to cookie cutter, send it to a lab.
Yeah, definitely. Although we work with labs, there was very few cases that were cookie cutter. There were some. There was defective products all over the city, and they would fail every so often, but those we would very quickly get through, because we'd look and say, yeah, that's a defective product, and we'd spend most of our time on the more complicated, unique situations that actually require a lot more brain power. I'd be in a hospital operating room one day, I'd be inside of a metal smelting furnace another week. I'd be shooting pumpkins at cars to test the integrity of your windshield another week, and that's how random things actually were.
But the pumpkin story sounds pretty good. I don't know if this is the most unique test you did, or if you could tell us more about it.
It was probably the most unique. So what happened was somebody was driving down the highway. Someone else threw a pumpkin from an overpass. The pumpkin went through the windshield and injured somebody, injured the passenger actually. and there were some records that show that that particular vehicle had a stone chip in the windshield. And the question was whether that stone chip made the vehicle more likely to injure the passenger because the stone chip acted as a stress concentrator. And if so, then how much did that stone chip contribute to the injuries of the individual? So there's no book out there. We don't know whether the pumpkin will simply smash or whether the stone chip will actually be a problem to the occupants of the vehicle. So we shot pumpkins out of a pumpkin cannon at windshields of the exact same make and model car with a high-speed camera measuring the speed of the pumpkin.
What would you say was your best or the most fun experience you had working as a forensic engineer?
One time, an individual swallowed something, made her sick, ended up in the hospital. Surgically removed that thing, ended up being a little wire about this big, but a quarter inch, less than a half a millimeter in diameter. They asked us where this came from. It seemed impossible to figure that out. But sure enough, we got the composition, we looked at it in a microscope, we saw that it had weird wear patterns, we traced back her history, and it turned out it was from a restaurant that she ate at, and had the fry, and not a McDonald's, but where they make fries, that those baskets, the baskets were fraying. And so the little tiny piece fell off the basket, and she ended up ingesting it with her food, and that's where that component came from.
After working for 9 years as a forensic engineer, you recently founded your own company, Mitigateway. Can you tell us about that company and what it does?
When you think of the world, there's millions of products. There's chairs, and there's planters and railings. There's millions of products, and some don't work out quite well. So there's defective products, and we have recalls, and we have just products that are problematic but don't get recalled. And we have these products scattered throughout the country and the world, and a lot of these defective products will be unknown to the person using them. Let me ask you, how often do you check the Health Canada recall website?
I don't think I've ever checked.
Right, and you're not alone. Most people are like that. So most people aren't checking whether a certain plumbing component that connects their plumbing to their toilet has actually been recalled, right? Like, even if they are checking the website, they're not looking for that. But I've seen those components cause millions and millions of damage because of a certain type of plastic from which the component was made that happens to react with chlorine, and chlorine's in our cleaning chemicals, and chlorine's even in our drinking water. So that plastic deteriorates and breaks, and suddenly your toilet tank is flooding your house instead of just sitting nicely waiting for the next time you use it. So those defective products I wanted to find, and I wanted to eliminate.
Do forensic engineering companies tend to take people straight out of university, or are they looking for people who already have work experience? What kind of candidates and what kind of backgrounds would they be looking for?
Here's the biggest thing that we would look for back in the day. Look for communication skills and problem solving skills. We can teach you the technical skills, but if you can't communicate, that means you can't interview people. That means you can't be compassionate with them in that stressful situation. That means you also can't boil down the complicated science into a simple soundbite for the lawyer or the insurer to understand. And that probably means you aren't going to be a good forensic engineer, because these communication skills are, like I said, half as important as your technical abilities. So we'd be looking for those which are hard to train, and we'd be teaching you those other technical skills over time, which are, I think, easier to train.
Right. Do you think that graduate school would help with those as opposed to just doing an undergrad?
I think if someone uses graduate school to advance both their half to the brain, the creative, the public speaking, and the technical, then it would help. I got to do a lot of presentations in my grad school. I got to join things like Toastmasters and better my public speaking and teaching. Usually, as you get to TA in grad school, that really helps. So I think if you focus on both in grad school, then it would help. If you focus just on one, you don't focus on those communication skills, then you're just bettering yourself technically, but not very well suited for forensics. Maybe more suited for design.
So what kind of things do you think a candidate with both sides, how do you think they could best stress those things in an interview?
Well, the interview process is easy at determining, or almost better at determining the communication skills. And just the way that you approach the front desk. The receptionist that worked there would actually be interviewing you the moment you came in. We'd pick up on those cues, starting from the receptionist down to meeting with everybody on our team, and then we would somewhat assume you knew the technical because you graduated from engineering. But that's what we'd be doing. We'd be looking at your ability to communicate some of the technical, and assume you knew the rest, but always looking at your communication skills. We've had people do presentations. There's one candidate that we interviewed right before, a month or two before I left, and he taught us a lesson about something that he did his PhD on. And that's how we gauged his communication skills, and we hired him because they were good, because we learned something. So that's probably the best way to stress your communication skills. Maybe offer to teach something to the interviewing committee.
So are most people applying to jobs that are posted, or are they just calling the companies? How does that process work?
It's a bit of everything. Like I said, there's no direct path. We post every job, and we do often get candidates, but we're constantly tapping our personal networks within ASM, within the industry, and within friends and colleagues.
Does it matter what stream of engineering they're coming from? If it's materials or mechanical or biomedical, civil, is there any sort of preference for disciplines in engineering?
No, because you'd end up just doing different projects. So I wouldn't be working on too many building collapses as a materials engineer, although I did assist in some, because some components failed that caused the building to collapse. But I wouldn't be looking at them all day long, and I wouldn't be the lead. But if you did civil, well, then you'd be looking at building collapses, you'd be looking at bridge collapses. And in biomedical, you'd be looking at auto accidents, you'd be looking to assess injuries. No preference. Every industry has a forensics aspect to it, because every industry has designing and manufacturing within it.
Do you have any other advice for someone interested in forensic engineering or failure analysis, whether a student or a recent grad?
If you're determined to do forensics, and there's nothing for you but forensics, there's 5 or 6, maybe 7 forensic companies in Canada. At any moment in time, one of them's probably hiring. So don't just pick one, pick any of them, and just apply to that one position. And if you don't get in that year, don't waste your 6 months waiting for the next position. Take that course, and within that course, do well on your projects, make contacts, go to ASM failure analysis committees, and constantly keep up to date with the people in those companies. Then the next time that they have an opening, they'll keep you in mind. But sometimes it just takes a while. If you want to do forensics and there's just nothing now, it could be a year before a job comes up, because there's only so many jobs. Don't just sit at home and wait for that perfect opportunity. Go get a different job. So in that other job, you'll be making money, which is important, but also just learning skills. You'll be learning customer service skills, you'll be learning manufacturing skills, you'll be learning problem-solving skills, and maybe you'll like that job actually even more. And now you won't waste a year. But do something. Don't just wait and wait for that perfect opportunity to come up, because it takes time. So have it in the back of your head, but do other stuff in the meantime.
Thank you, Paul. It was great speaking with you. Thank you all for listening. I'm looking forward to seeing what happens with Mitigateway. If you guys want to find out more, feel free to check out that website. And also to find out more about all the ASM perks of being a member and where it can lead you in terms of networking and the materials information, feel free to check out asminternational.org, and we'll see you next time.